Hi, welcome to video 8.5b, more integrating using partial fractions. Here's an example out of the book. You have the integral of this polynomial over this polynomial. The first thing you always want to do is check the degrees. In this case, the degree of the numerator is less than the degree of the denominator, so we do not have to divide. You'll factor the denominator, which is x times x plus 1 squared. You'll set up your fractions. You'll need x as a denominator, x plus 1, and x plus 1 squared. Don't forget you'll need the x plus 1 as well. So you take this fraction with the denominator factored. You have these three fractions here. You're going to multiply both sides by the LCD, which is x times x plus 1 squared. Once you've done that, you will end up with this expression. So remember, what we're going to do is purposely let x equal -1 so that this will become 0. When we do that, replacing x by -1 on the left, we get -9. This term is 0, this term is 0, and we have -1 times c, so c is 9. The next thing we're going to do is we're going to let x equal 0, which will make this term disappear. So plugging in 0 on the left, we get 6. Plugging in 0 into these last two terms, we get 0, but here we'll get a. So now we have c and we have a, but we need b. Now there is no other number we can plug in that's going to make one of these terms 0, so we can pick any number we want. I think 1 is easy. Plug 1 into the left side, plug 1 into the right side, and you'll have 2 squared is 4a. Plug in 1 here, you'll get 2b. Plug in x equals 1 here, you'll get c. But remember, we know a is 6, and we know c is 9. So we plug that in, and we solve for b. Okay, so now we have the actual integral. Remember, we had written it as a over x, so a is 6 over x, b is -1, and c is 9. Now we have to integrate this. What'll happen is this is 6 times the integral of 1 over x dx, which is ln absolute value of x. Same idea here. You'll let u equal the denominator. The derivative is just 1 dx. So we pull out the -1. We have ln of our absolute value of our u. This is, of course, a very different situation. This is x plus 1 to the -2. Let u equal x plus 1 du is dx. So we have u to the -2, which we integrate, and we get u to the -1 over -1, the 9 I just pulled out. And then it's just a question of rewriting it. Of course, this is a fine answer, but they might decide to use their log properties, bring the 6, make this x squared, and then change the subtraction into a division. I do want to make sure you understand that when you decide to do some problems out of the book, you cannot do any problems with quadratic factors. So like if you have a denominator of x squared plus 3, which cannot be factored, and that is quadratic, you're not responsible for that. Okay? Alright, so again, we check the degree of the top over the degree of the bottom. We're fine. It's less. Factor the denominator, etc., etc. We'll need denominators of x and x minus 4. So you multiply both sides by the LCD. You're purposely going to let x equal 4. That'll give us b equals 3 halves. You're purposely going to let x equal 0. That'll give us a is -1/2. So you rewrite the integral as a, which is -1/2 over x, plus b, which is 3 halves over x minus 4. And again, these will be ln's. Again, this is a fine answer. Keep in mind that for multiple choice, they might decide to use the properties. First you use the power property, and then the product property. And then I'm just rewriting this x to the -1/2 as over x to the half. Here's another one. Degree of the numerator less than the degree of the denominator. Factor the denominator. We do that in pairs. And you will end up, once it's fully factored, with x minus 1 times x plus 1 squared. It's necessary that you do look at this as x plus 1 squared, because you'll need a denominator of x plus 1 squared and a denominator of x plus 1. So we have our three fractions. Multiply both sides by the LCD. Let x equal -1. Let x equal 1. And then there is no number we can let x equal other than -1 and 1, which will make one of the terms 0. So pick any other number. I picked 0. and then you end up with a minus b minus c, but we have a and we have b. Once again, you then rewrite it, and then you be careful, this will be an ln, this will be an ln, this will not, because this is 1 over u, this is 3 times 1 over u, but this is negative 2 over u squared, so be careful. And again, they might use log properties to simplify. Now, this one, be careful, degree of the numerator is greater than the degree of the denominator. So you're going to have to divide, make sure, and it has to be long division because this is a quadratic. You can't do synthetic. Remember to fill in the missing terms. There's a missing term here of x squared, so 0x squared. So you do the long division, blah, blah, blah. Don't forget you are subtracting. I don't know why that minus sign is missing. Let me fix that right now. So there is a minus sign right there. Okay. So when you finish dividing, your quotient is x minus 1. Your remainder is 2x plus 1. So remember, it's quotient plus remainder over divisor, and there's your divisor. Now, this fraction has to be done by partial fractions. The degree of the top is less than the degree of the bottom. So separately over here, if I just do that, the denominator factors into this. That gives me 2 fractions, etc., etc. You'll find a and b are 1 and 1. But don't lose this part. You still have this integral of x minus 1 plus, and now you break up with the partial fractions. And of course, the rest is history. And then, of course, using the log properties to simplify.